So in this question, we have an atomic nucleus that was traveling with a certain velocity, and then all of a sudden it emits an alpha particle. An alpha particle, you can think of it as a helium atom. So we know that the original nucleus, it has a remaining mass of 222 U, and its velocity is 280 meters per second, and we're asked if we know the mass of the alpha particle, what is the speed of it? So let's first draw a graph of what's happening. Initially, we have this nucleus that was traveling, and let's say it's traveling with a speed of v. And afterwards, it departs into two different particles. The remaining of it, let's just call it A and call it B. This A could be the alpha particle. So this alpha particle will be moving in a direction, and the remaining of the nucleus, that's 222U, is moving with a changed velocity VB, and this is VA. And I do not actually know whether which way these particles will be moving. Right now, from my drawing, it looks like VA is in the opposite direction as V, and VB is in the same direction as V. But it doesn't matter, because if I assume the wrong direction, I'll just get a negative sign in the final result. So let's write down all the numbers we already know. It was initially moving at 320 meters per second. So its initial mass would be 226 U, because it's the sum of both of them. Oh, sorry, the original nucleus was 222 U. So, and then this 218 U. Great, sorry. So afterwards, it's moving at 280 meters per second. That is VB. We want to know what VA is. So again, since there are no external forces, this is a typical conservation of momentum question. And we can write MA plus P initial. Let's write this way, equals P final. P initial is, I have the mass of both particles traveling at the same velocity V. Afterwards is MA VA. Let me call it prime, just to indicate that it's after the emission, VB prime. So right now we need to know what VA prime is. So to do that, we just arrange this equation so it has VA prime on the left-hand side. Minus MB VB prime over MA. So this is the equation we have, and then all we need is to plug in the numbers. The original nucleus has a mass of 222 U, times velocity is 320 meters per second, minus afterwards is 218, MB is 318 U, times 280 meters per second, all over 4U. Actually 4.0. Let me respect the significant number given to me. That gives me 2500 meters per second. Yes, so that is the velocity of the alpha particle. And we can see that, so I did not convert everything to kilogram because everything is in units of U, so it will cancel out. And what else? Alpha particle, we can see VA prime is positive. So what it actually means is that I was assuming the wrong direction here. Alpha particle was actually also moving this way because it's positive. And because and actually we can kind of observe that because the remaining the particle B, it actually slows down from 300 to 280. That means a part of its momentum in that direction was distributed to particle A. So A must be moving in the same direction. If A moved in the opposite direction, B would actually speed up. So I assumed the wrong direction in my graph, but my calculation still gives me the correct sign and the correct direction. So alpha particle will be moving in the same direction as the original particle, and so is the rest of that particle.